Hello, everybody, and welcome to today's presentation, 4 Best Practices to Meet Compliance Requirements in Kubernetes Environments, brought to you by Sysdig. I'd like to introduce you to our presenter, Pawan Shankar. Pawan has over 8 years of experience in enterprise networking and security. Previously, he worked for Cisco as an SE and a PM, working with large enterprises on data center, cloud networking, and security solutions. He also spent time at Dome9, acquired by Checkpoint, leading their security and compliance product marketing efforts. He is now a senior PMM at Sysdig, focusing on their container security product, Sysdig Secure. Pawan holds a Bachelor of Science in Electrical Engineering from UCLA and an MBA from UC Berkeley.
Okay, thank you everybody for attending. My name is Pawan Shankar, and I'm a security product marketer here at Sysdig, focusing on the security and compliance products. So today's topic, we'll be talking about 4 best practices to meet compliance requirements in Kubernetes environments. So let's get started. So as we all know, we're experiencing radical changes in the application architecture today. So the classic monolithic application stack really depends on the application residing on some form of middleware, connected to a database, running an operating system, either running on bare metal or some virtual machines, connected to servers and storage. And a lot of times what we're seeing now is the catalysts that are driving this change, such as infrastructure components like Docker, orchestration tools like Kubernetes, and even the public cloud underlying infrastructures are accelerating the adoption of cloud-native applications, and enterprises really are moving towards these cloud-native architectures that leverage microservices to deliver more modular applications. This modularity really allows developers to work faster and more independently, especially across multiple clouds. And with the scalability of microservices, it's really become kind of the foray into more of a DevOps-focused deployment model. This trend has started to take notice as well. Previously for many years, containers were really used in dev and staging environments, but now they're really starting to take helm in production as well. Gartner recently reported that 50% of enterprises will move containers into production by the beginning of 2020. And as we're seeing a rapid adoption in containers, the one thing that's top of mind for many large organizations is security and compliance, and for good reason. What we're seeing today are that Kubernetes and container threats are also on the rise. So going back to a year ago at Tesla, this was in the news where a cryptojacking incident occurred at Tesla, where hackers infiltrated Tesla's Kubernetes console, which was not password protected. And within one Kubernetes pod, the access credentials were exposed to Tesla's AWS environment, which contained an S3 bucket information that had sensitive data around the telemetry for Tesla. Also last year in March, there was an etcd exposure where a security researcher had queried the popular Showdown search engine and found almost 2,000 or more servers exposed online that were running etcd with credentials and passwords exposed. And this really is a distributed key value store that's used in Kubernetes today. So this was a very big credential leak last year. Also in middle of last year in June, Weight Watchers, a company, exposed their Kubernetes admin console via having no password on it. And this really granted anyone who knew where to look, it was port 10,250, access to these servers without the need to enter a username or password. Also in June, there was a GitHub CVE that was announced, and this vulnerability was discovered in Git, which allowed escalation of privileges in Kubernetes if unprivileged users were allowed to create pods with Git repo volume. Circling to this year, even though we've barely spent time this year, just February, we've already had 2 key vulnerabilities that were discovered. The recently disclosed vulnerability in Kubernetes dashboard, this CVE allowed users to escalate privileges within the Kubernetes cluster using the dashboard to access information that they're not granted access to. And a user could skip the authentication and query resources that the service cannot access. And finally, this one is a popular one that was just announced in this month, a popular CVE around the runc environment. So runc is really the underlying container runtime between infrastructure such as Docker, CRI-O, Containerd, and so on. And this new vulnerability allowed a compromised container to overwrite the host runc binary and gate root level access and file access to the containers. So and the last two of these, they're actually Sysdig blog posts on how you can detect these with open source tools as well. So what are people really trying to do to protect their Kubernetes and container environments, and why is this really happening? So for one, we're seeing that a lot of people are trying to bring in traditional tools into to secure their container environments, and really legacy security tools don't work. Modern software deployment practices put a lot of pressure on security teams and on security infrastructure, and this really impacts the ability to deliver security more successfully when using traditional tools for a few reasons. Number one, poor visibility. So you really don't have visibility into vulnerabilities inside containers using these traditional tools, which leads to a false sense of safety. Containers really break your legacy tooling, and network-based security tools like a firewall really can't see inside these containers. So one recommendation would be for organizations to really adopt tools and processes to validate and enforce security and compliance as best practice. And this should really include centralized reporting and monitoring of your compliance and security posture. The second big reason is also that security and DevOps are not really coupled tightly just yet. Security wants to be a part of the DevOps movement, and they want to be part of this process that they can help code get into production quickly, but also securely. The problem is that legacy security tools are not built for this and can't keep up with the speed of development, especially in this new shift from monolithic development to more microservices-based deployment models. The third thing is that there are just so many security tools, and most of these don't work in a containerized environment. And with such fragmentations of tools, there's a lack of contextual awareness. And really, when you add in orchestration tools like Kubernetes, you're really breaking down these edge firewalls that have no context. And finally, containers are really black boxes, and you add in orchestration, massive automation on top of it, it really adds a lot more complexity and makes it harder to secure your environment. And especially when applications are distributed and scaled across the public cloud and on-prem, based on resource availability, the traditional tools can't operate at the scale of this deployment, manage the way to change in the container environments, and really have true visibility and provide effective security across these different deployment models with different policies that are running. So really, one of the recommendations here is to utilize a a cloud-native security solution that can monitor your container environment and provide more precise detection and anomalous activity and malicious activity that's happening. You still need a perimeter firewall, but at the microservice or app level, you need to start considering more cloud-native security tools. And according to NIST 800-190, their guidance is also to use a dedicated container security solution capable of preventing, detecting, and responding to threats aimed across the container lifecycle, including during runtime. So now that we talked a little bit about the status quo and why these legacy tools don't work, let's talk a little bit about what you need to do from a security perspective and what are some of the challenges. So there are a couple of key challenges for ensuring container compliance. Number one is the fact that there's a higher container density. Container density has increased by about 10x, not more. And what this really means is that there are 10 times more things that you need to pay attention to. And this was based on a survey that Sysdig did about a year and a half ago, where we took a snapshot of our customer environment and sampled about 50,000 containers. And we saw that the average per host was about 10. Some levels we saw 95 to 100 to an upper limit all the way to 200. But what does this really mean for compliance? The key questions you should be asking is, how do I gain visibility? And is my instrumentation and tools today container friendly? From a PCI perspective, is there a clear way to tell which containers contain PCI or PII data, and what are the network connections? A big thing in PCI is dynamic network topology maps, which is an initiative for PCI. So do I have that visibility into my container environment as my container starts to scale by over 10x? The second challenge is the proliferation of ephemeral services. So a lot of these containers are a large web of a lot of these applications are a large web of containers and microservices that are distributed in ephemeral. So there are no more static, servers. Many of these containers are up for a few minutes or even 1 second. Recently it was discovered that the average server lifespan in public cloud is about 127 minutes. Right? And many of our customers are running thousands of containers that are being spun up and down. And especially with orchestration tools such as Kubernetes, Kubernetes can spin up and kill a container multiple times a day, or even in the matter of a second. So the real question becomes, with this opaque nature and kind of an immutable configuration, how do you gain visibility into the health, performance, and reliability of containers? And what this means for compliance is, how do you continuously audit your containers, right? From an audit perspective, questions such as how long, which users accessed this container, what files they touch, did they Docker exec, or did they come in via the Cube or Docker API? How long did they spend time in the container? All of these questions arise from an audit perspective, and were there any files accessed, were there any directories touched, anything else changed, activity logs. It becomes crucial when it comes to ephemeral services like containers, and it's hard to manage with any sort of traditional tool today. The third big challenge and kind of a deeper insight is that containers are not equivalent to orchestrators. And what I mean by that is that they're fundamentally different and they require different policies for management. So really the question becomes, how do you manage both of these policies effectively? And more importantly, how do you use both of them to enrich one another? So for example, orchestrators give you metadata and telling you that these are the containers that are expected to be running in this Kubernetes namespace. And if you're able to detect another container that's spawned in that specific namespace that shouldn't be there, you should be able to take the action to quarantine, stop, or kill that container. Whether it's in a public cloud, AWS region, and someone launches a privileged container, using the metadata from Kubernetes and the cloud providers, you should be able to better enrich that context and really manage that policy better consistently, whether it's in the public cloud, on-prem, and so on. And the last thing I think, which everybody probably resonates with, is really the speed of DevOps. It really makes compliance obligations difficult. And regardless of the fact that applications are going through a more DevOps model for agility, enterprises still have to comply to compliance obligations, and not adhering to them can be expensive. And the cost of compliance can be heavy, and you can have penalties and fines. And based on a recent Ponemon report, the average cost of data security is about $2 million, and sometimes even north of that with frameworks like GDPR, for example, that can pose pretty heavy penalties on organizations that fail to comply. So really, the questions coming up here for many of our customers is, how do I gain visibility? Number one, how do you continuously audit? How do you, consistently manage security policies, before deployment, during runtime, and how do you really mitigate the cost of compliance by deploying securely, but also being agile and quick. So how should you really be looking at your cloud native compliance solution? So now we'll explore 4 key steps you must take to really ensure that you're continuously meeting your compliance and security requirements for your microservices stack. So starting with the pre-deployment phase, this is prior to you deploying your applications into production. And a lot of good can be accomplished if you start things off securely, right? So why is this really the first step? So in terms of securing pre-deployment. So if you're a security operations person, you really want to ensure image scanning is a step that your developers complete before deploying any application. As a DevOps person, you also want to identify images that have failed scans in your CI/CD pipeline and reduce time spent finding and remediating security issues. Also, if your container deployments are primarily based on open source packages, you want to make sure that you're not exposing your organizations to security compliance risks, potentially based on vulnerable packages. So really, this becomes the first step where you block images from being pushed into production by scanning them early in the pipeline, in the build phase. So really, this is the shift left model that we're hearing in the DevSecOps terminology, and really tightly couples DevOps and security together by baking in security early in the pipeline and integrating, a security check pre-deployment in your CI/CD pipeline and allowing only, clean images to pass. So integration with CI/CD tools such as Jenkins, Bamboo, CircleCI, Concourse, Code Pipeline is one of the things that you should be thinking about. How do you natively integrate security into that pipeline? The second place, from a scanning perspective, is to think about your registry. Really, your registries like Docker Hub or your private registries or your JFrog Artifactory, ECR, GCR, Quay, and so on. Really scanning those images that are being pulled from the registry to make sure that they're clean. If you are deploying Kubernetes, one of the other ways you can ensure compliance security is really prevent vulnerable images to be pushed into production by integrating with the Kubernetes admissions controller and blocking any sorts of failed images from ever being deployed by Kubernetes in the first place. So that's a great way to also leverage the native Kubernetes admissions controller and integrating security there. So now that you've kind of scanned, and done the first step of security and compliance for Kubernetes, the next check is to make sure that you want to ensure that your environmentals are healthy. And this is really checking and making sure your Kubernetes and Docker configurations are compliant. Lots of those exposures that we talked about, Kubernetes dashboard, etcd, credentials leak, were all kind of a result of undetected misconfigurations on your Kubernetes console, etcd, and so on. And this could really be prevented by continuously scanning the configuration against standards that come out of the box, like CIS benchmarks for Kubernetes or Docker benchmarks. A really good way to ensure that your orchestrator and container posture is compliant. Next, as you start running these applications on the container, you want to think about what your runtime security looks like. And starting with your applications, you want to see the performance and really monitor the performance, health, and reliability of your applications and detect if there's any anomalous behavior. For example, is there a sudden spike in CPU memory of a container in a cluster that could potentially lead to a denial of service attack? What does my network traffic and latency look like across my different clusters and across my different environments, and so on. As part of this is also assessing your compliance posture over time and really seeing trends over time to say, hey, in the last 6 months, how have I fared against, CIS? How's my Kubernetes control plane fared against the CIS benchmark? Has it been improving? Are there anomalous spikes that I'm seeing? Are they, things that I can draw some insights from? The sort of trends and analytics of your security posture can be really enriching in terms of your compliance posture. As you're running these applications, you may also want to consider, do you have an understanding of your deployment model? Am I seeing all my metrics from my containers, from my host level metrics, network level metrics across my infrastructure? Do I have visibility into my multi-cloud environment? If I'm deploying multi-cloud, do I understand what containers are running in my AWS regions versus my GCP regions, and so on? And also understanding at an orchestration level, if you use OpenShift or Kubernetes, do I understand the compliance posture of any specific namespace? And do I know what changes were made, for example, from a kube audit API, who did what in Kubernetes? So all of these things, from a runtime perspective, are crucial. So enforcing these runtime policies becomes critical. So did someone spawn a terminal shell, or did someone modify a binary directory, or did someone launch a privileged container in AWS? Are all questions that you should be able to have answers for when you actually have containers running in your environment across different cloud providers and different infrastructures. So we kind of talked about the scanning. We talked about orchestrated and container posture. We talked about runtime policies, and finally, the last thing is post-deployment. So this really is around the audit and forensics. So the key things here becomes, are you really able to investigate policy violations and do forensics, right? Are you able to alert on incidents and have a response in place? Are you able to analyze any activity, whether that's file activity, process level, user activity? What happened in a given period of time is important. And really less of a tooling question, but more of a cultural and workflow question is, has this become part of your workflow? Do you have processes and teams in place that have well-defined procedures that they can follow when an incident occurs? And really, the last thing is proof of compliance. So can I prove auditors that, hey, nothing was compromised according to PCI at the most granular level of detail as possible if a certain breach was happened? How do you show that proof? So this kind of becomes the 4 steps to really making sure your entire container lifecycle is compliant, starting from scanning, your orchestrated container posture, your runtime, and finally your audit and forensics capabilities. So some insights that we are seeing from our side that I wanted to kind of summarize here is compliance is really becoming an end-to-end, container lifecycle requirement, starting with, hey, are my images compliant? Is my control plane in Kubernetes compliant? Am I making sure that my runtime configurations follow best practices and compliance processes? And finally, can I do auditing and forensics to show that nothing's violated PCI or other frameworks? The other thing is that regulations really are range from very prescriptive CIS to more broad guidelines like HIPAA that require enterprise organizations to really interpret rules for themselves. And a lot of times what we're seeing is out of the box frameworks in these container security tools are becoming a boon for customers that they can just schedule and run on an ongoing basis. There's also an increasing interest in custom policies for organizational specific checks. And the last thing we're seeing is, a trending of your compliance posture over time can provide some unique actionable insights and give you a better handle on kind of seeing not just seeing the trees, but kind of seeing the big forest level view as well. So ultimately what it boils down to is that the cloud native really can't operate with a traditional security model. It really requires a new security stack, whether you're looking at tightly coupling DevSecOps, whether you're looking for more vulnerability management, runtime protection, forensics, or audit and compliance across your container lifecycle. Really, a cloud native visibility and security platform can really address those use cases and needs that we're seeing. So transitioning a little bit into what Sysdig does. I'll walk through a little bit about the Sysdig platform and give you an overview of us. So Sysdig is open by design and built for the enterprise. The co-creator of Wireshark, Loresh Dejwani, if you guys are familiar with Wireshark, was the co-creator of Sysdig as well. So there's a lot of pedigree and credibility coming from the open source community here for Sysdig. We're also talking about open source. We're also a CNCF contributor, Cloud Native Computing Foundation, where we donated Sysdig Falco, which is our runtime security project that can detect any, you can create policies on any single system event. And it's also the creator of Sysdig Inspect, another open source forensics tool for audit and compliance purposes. We have 300 plus enterprise customers, over 100 million capital raised from top VCs, and we're ecosystem partners with Kubernetes, AWS, OpenShift, Docker, and so on. So a little bit about the architecture for Sysdig. We're really collecting deep metrics at your application, container, host, network, file, all of these metrics, and enriching them with metadata from the cloud providers, orchestration tools, to really build a platform that either can be delivered as a SaaS on-cloud service or as an on-prem software that you can deploy behind your own firewall on running on a bunch of containers. And on top of this platform are the use cases around monitoring, security, forensics, and more that we offer for our customers. So diving a little bit deeper, the way Sysdig works is on a host OS, you have multiple applications and containers running, and Sysdig can either run as a container, privileged container, or a root process on that same host, and essentially install a kernel module that modifies the kernel to send every single system call that's traversing that kernel to our agent. And this is done without any instrumentation into the other containers in that user space. So every single system call, what does that mean? That means that Sysdig has the ability to see every single file activity, process, commands, network activity, pretty much anything that's a system call that goes to the kernel. And this is really the kernel instrumentation that we deploy that allows us to see all the application, container, host, and network metrics. And we can monitor, detect, and protect, and troubleshoot from a single instrumentation point, one single agent. On top of this, we enable a service-oriented intelligence capability, which allows us to pull in metadata from Kubernetes, native integration with Kubernetes, OpenShift, and the cloud providers that we pull in the metrics to really enrich all of those metrics that we're getting from the system calls and giving you a more service level and logical level view of your applications. So questions such as what is a specific namespace in Kubernetes look like? We can give you that service vision pretty instantly through the platform. So the vision really here is to unify a unified cloud native intelligence platform. So a single platform that can allow you to accelerate your development of reliable, secure, and healthy containers. So what we call as build, run, respond is the container lifecycle, where starting with the build phase, really this is pre-deployment where you're able to block multiple images, visualize your topology, and so on. At runtime, you can ensure you're compliant at your cluster level. You can ensure you're compliant with your runtime configuration. You can monitor application performance, block zero-day threats, and so on. And finally, the response side is the post-mortem, if you will, where we can proactively alert you on incidents, reduce any mean time to resolution with forensics, and you can capture detailed audit records as well. So that's kind of the flow of the container lifecycle here. And now I'll transition over to a quick demo of the platform, and we'll follow the same build, run, respond framework as well in the demo. So starting with kind of the build phase, which really is around scanning and making sure you block images, multiple images from going into production. You can leverage out-of-the-box scanning policies, and you can see here we have policies for NIST, PCI, but also Docker best practices, and any other specific policy that you would like to create for your organization requirements. So if you check the default policy, for example, you can see here that you can create kind of many different permutations, and we're very flexible in how you create policies. So you can say a specific Docker instruction file should have health check, and if it doesn't exist, create a warn action. If a package, if available, an OS or non-OS package with the severity that's high and has a fix available, if this is deployed, then create a stop action. And if a Docker file exposes SSH, create a warn action, and so on. So you can create these rules for your own security and compliance requirements, but also create them for DevOps best practices as well. So you can say a specific image should not exceed a certain size, say like 4 gig. And this allows you to make sure that you're not pushing cluttered images into production, potentially by a developer that is unknowingly doing this. So a lot of security compliance, but also best practices from a DevOps perspective. Now, we talked a lot about, going back to that slide of, CI/CD integration, integrating in your pipeline. We natively integrate with Jenkins and also have API integrations for Circle CI, Concourse, Bamboo, and so on. So in your pipeline here, if I go into my build history here, I can quickly see in a Sysdig pipeline, in a Jenkins pipeline, I have connected, have pointed the Sysdig API for Jenkins to leverage the scanning policy, and it generates a report every time this build runs. And you can see here, this scan generated 24 stop actions, 73 warn actions, and the final action for this build was stop. And you can see here that the reason for the stop action was that a vulnerability was found in an OS package, fix was available, but it was still being pushed, so this was a stop action. And this is triggered by that policy that we had just recently seen here, where this created a stop action if a high severity vulnerability was exposed with a fix available. So you can create these kinds of policies and make sure that no vulnerable images are being pushed to production, and really blocking that process earlier in the pipeline and container lifecycle. From a registry perspective, again, we integrate with all your main registries, ECR, GCR, Quay, and any Docker V2 compatible registry. From a runtime perspective, you can also detect any images that are running in production. So the cool thing about this is you can see specific to your hosting containers that are running, or you can actually see it at a Kubernetes level and see, show me, if I'm an application owner, show me a specific namespace, such as example Java app that I care about as an application owner, and show me the risk posture and all the images pertaining to this specific namespace. And you can see here that there are 7 images, 5 of them that are failing in the last hour. And if I click these click the specific image, I can see what packages were vulnerable, the specific policy that were triggered, and actually dive into the vulnerabilities and see the specific packages and see where their CVE, whether their CVE exists or not, and actually explore the contents of this image as well at an OS level, or explore the packages such as Python, Node, Gem, and so on. So all this is from a scanning perspective. So the next step we talked about CI/CD, we talked about registry. The next big thing is compliance, control plane compliance. So we're really looking at your Kubernetes control plane here and checking, is my API server configured correctly? Is my etcd configured properly? And are there any specific configuration files that trigger any fail actions here? Similarly, at a Docker level, we can also check your compliance. Are you enabling SC Linux here? Are there any privileged containers that are not used? Is someone running an SSH daemon on the container? All of these can be run as compliance rules and run on an ongoing basis to detect any sorts of misconfigurations. Now, a lot of times, you see a pass-fail report, which is valuable, but your compliance teams are really looking for posture and trends over time. And we can give you that via the Sysdig Monitor platform that allows you to see these compliance reports over time. And you can see that an overall pass rate of 18.6 compared to a day ago. And what was my pass rate over time for specific sections, for specific test cases? I can see trends for etcd, for example, over the last 6 hours, 2 weeks, whatever time frame you would like. So seeing these as metrics is pretty valuable and helps you spot anomalies quickly. Now, on the visibility side, say you have a bunch of containers running, you can actually also this view, and I can see I can kind of slice my environment in many different ways. And this was kind of the service vision that we talked about in the slide, where we're enriching all of the metrics from metadata from your Kubernetes and clusters and so on. So here you can see, a cluster nodes view. So you can see kind of an AWS and a GKE cluster. So giving you essentially a hybrid, multi-cloud view of your environment. You can also see at a host and containers level, this is giving you more at what are the specific hosts that are running. I can see it by AWS instances. I can see it by deployments and pods and so on. So for a specific namespace, I can see and drill into what that posture looks like. And from a topology perspective, you can actually see, show me network traffic for my Kubernetes environments, or show me specifically for this Java app. And what's interesting here is that you can see this specific namespace, what was the traffic over the last 1 hour, and actually drill into that namespace, drill into that deployment, go into that pod, and actually go to that container and see that the two processes that are running in here, Nginx and Tomcat, and what are the traffic through that. So this kind of ability to zoom from a top level view all the way down to the process is pretty unique to the platform, and add an ability to slice this from multiple different perspectives. So this kind of gives you the visibility. Again, this network traffic is big for companies that are looking for PCI audit and tracking of their network traffic, and so on. Now going back into kind of the runtime side, Sysdig kind of has tons of runtime policies that allow you to check the policy violations in your container infrastructure. So did someone modify binary directory? Did someone launch a privileged container? Did someone run a shell in a container, which could be pretty bad, right? And all of these are based on Falco rules. So we talked about Falco being that open source project that we donated to the CNCF. So a lot of these rules are coming from the open source community, also being enhanced by our threat intelligence teams to really build enterprise-ready compliance and security rules. And you can actually click on one of these rules and see what it looks like. Rules that can be created for whitelisting, blacklisting processes, containers, network ports, files, system calls, and actually leveraging Falco rules. So you can actually see the different Falco rules that we already have available, so that can be leveraged for out of the box. And there are a few things going on here, but the main thing here is you can actually take actions from this and say, if this specific someone wrote below etc and installer, do nothing, stop the container, pause it, and also create a capture file. And we'll speak about capture file in just a moment, where you can take a full capture dump of this event, sort of like a TCP dump, if you're familiar with that, of all the system calls that traversed 5 seconds before and 10 seconds after the event. Now, let's actually go into the last phase. So all this was runtime policies and runtime detection. Let's go to the last phase of incident response and more of the forensics capability. So you can see again, in the last 2 weeks, I just selected show me all the policy events that have happened. And you can see, obviously this is a demo account, but you can see something malicious has happened here. And if I click the terminal shell in the container, I can actually see some basic information saying, okay, this happened on WooCommerce app, on this pod, this deployment, and this is the container ID and host, IP, and MAC. I can actually go see the commands. What were the commands that were run for this terminal shell, and actually see that someone bashed into this LS, curled down a URL, tarred a file, zipped it, and sharded the bash history. So obviously this looks suspicious. Now, what I would like to do is go back to this and actually explore that capture file. So we talked about capture file being something that you could trigger if this specific policy happened. In our case, it was 40 seconds. And you can actually inspect this capture file in granular detail using that open source Sysdig inspect tool. So again, this is really where the Wireshark fundamentals start to play. And this is really built on the same flavor as Wireshark, where you can inspect all of the system calls generated in an SCAP file. So very similar to a PCAP file in Wireshark, you have a Sysdig capture file that's generated. And you can see here that in the last 40 seconds, we captured 70,000 system calls. And you can start saying, okay, show me what notifications, show me what were the commands that were run, what files were accessed, whether there's anything modified, and so on. And you can start to see here at the bottom that I'm seeing a certain trend appearing. So I can actually zoom in here and see what exactly happened in this specific, 1-2 second interval approximately, and actually go and click, okay, what are the commands that were run? And this should look familiar. We saw this in the secure portal as well, where someone bashed in and curled down a command. But what's interesting now is you can actually take a look at this command specifically and see what happened. So I can actually go into this, switch over to a directories view, and see what directories were touched, and actually see what files were accessed. And open this up, and if I open this up in printable ASCII, you can actually see what were the payloads of that file specifically that was written to. And this is pretty pretty unique to Sysdig and really helps with the granular level of detail that you can use this for compliance, PCI audits, and so on. And the big value here is that all of this is happening long after that container is killed. Right? Kubernetes might have killed this container in a second or 10 seconds and so on, but you have this complete audit trail and complete capture file that you can explore outside of production. This can be in an S3 bucket if you will, if you choose to. And you can explore this in granular detail and actually show auditors that, hey, this is exactly what was written to this file, and this is why we have or have not violated, PCI, for example. So this level of granular detail as to who accessed what file, what were the PIDs, UIDs, what were the actual file contents, all the specific details are all the things that you can do outside of production in granular detail using Sysdig Inspect. So that kind of wraps up my demos. Just to summarize, container lifecycle compliance is really an end-to-end journey, starting with image scanning, moving on to your control plane, your configuration compliance, your posture analysis, visibility into your applications, and then next up as we're looking at your runtime configurations and runtime policies, and detecting if there's anything malicious happening there. And finally, in the event of a policy violation, exploring that in further detail for audit and compliance purposes are kind of the journey that we have with Sysdig here as a security and compliance platform. So that wraps up my presentation and demo. I'll hand it over to the presenter again here to take it over.
Awesome. Thank you so much for the presentation. Now we will move on to the Q&A portion. We do have a couple of questions that have came in. The first question that we have is, how is Sysdig deployed?
Yeah, great question. So Sysdig is just deployed as one single agent running on your host. You have one single instrumentation point. You don't have to do any, sidecar or instrumentation on your container. You install it as a privileged container or a root process or daemon set or any other mode that you wish, and you can deploy it either as a consume it either as a SaaS application, or where most of our customers do is deploy it on-prem, which runs behind your firewall, running on a bunch of containers. So they can give you that that deployment model as well.
Awesome. We have one more question. So audience, if you do have any more questions, please post them into the questions panel. The last question that we currently have is, what is Sysdig's differentiation from other container security companies?
Yeah, that's a great question as well. Sysdig is really a unique platform that combines deep visibility into your cloud native and containerized applications, security on top, security and compliance on top of that, as well as post-mortem forensics, all within one single platform running with one single agent in the backend. And this really allows enterprises to easily manage and secure the containers effectively across whether they're deployed on-prem, in the cloud, or anywhere. And from a compliance standpoint, Sysdig really offers scanning policies for compliance, Kubernetes and container configuration compliance, compliance posture trends, runtime policies, and finally the audit and forensics that really provide an end-to-end compliance journey for your development lifecycle.
Great. Well, it looks like all the questions that we have, Pohan. So is there anything you would like to add before I close things out?
No, definitely check us out on the Sysdig website. There's a free trial for Sysdig Monitor today. If you're interested in the Sysdig security, Sysdig Secure, please reach out to us as well. If you're at RSA, definitely come by our booth. We'll be at RSA as well. So if anybody's interested, please come talk to us. Looking forward to talking.
Great. Actually, we do have a couple questions that have just come in. The next question is, how is Sysdig different from Datadog?
Yeah, that's a good question. From a Datadog perspective, and at a high level, they're really kind of more of a horizontal view where they're looking at APM, logging, metrics, and so on. But if you're really deploying containers and you're using Kubernetes, we're the kind of the vertical stack for your container applications and really can give you deep visibility, metrics, allow you to visualize multiple different from multiple different lenses, either at a Kubernetes level, at a host containers level, and so on. So giving you a lot of capabilities in the monitoring platform that are very built for DevOps and application owners running on containers.
Awesome. Well, with that, I'd like to thank you, Pawan, for a great presentation. I'd also like to thank Sysdig for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.